In this set of videos, we'll deal with factoring polynomials and dividing polynomials. For our first problem in the series, we'll deal with long division, in which we divide a polynomial by another polynomial. To do long division, the polynomial on the bottom we'll write on the left of a division symbol, and then the polynomial on the top we'll write inside the division symbol. So notice the polynomial that we had on top previously moves underneath this division symbol, and then the polynomial on the bottom we wrote on the left. Also, when you write your polynomials, make sure that you write them in order of power, going from largest power to smallest power. Note that inside of the symbol, we started with 2x to the fourth power, and then worked our way down from third power, second power, first power, and then finally the constant. Also, if there are any missing powers, make sure to include them, but write 0 as the coefficient. Now, long division will be the same 4 steps repeating over and over again. For our first step, we're going to look at the leading terms and we will divide those. Our first leading terms are 2x to the fourth inside the symbol and x squared outside of the symbol. We'll do that division first. If we divide, our constant on the top is 2 and the constant on the bottom is the invisible 1 because we didn't have one written. 2 divided by 1 gives us 2. And then x to the fourth power over x to the second power will have us subtracting the powers and giving us x squared as the power. We'll write that 2x squared on top of the division bar. Once you've written that 2x squared on top of the division bar, we'll multiply that 2x squared by each of the terms to the left side of the division symbol. The answers we get from that operation we'll write underneath our polynomial that's under the symbol. So we will take the 2x squared and multiply it by x squared, multiply it by 2x, and multiply it by -1. 2x squared times x squared will give 2x to the fourth power. 2x squared times 2x will give us 4x to the third power. And then 2x squared times -1 will give us -2x squared. Once we get those answers, for our third step, we'll change all of the signs for the answers we just got, because we will be subtracting those answers from the polynomial we started with. So underneath the division symbol, the 2x to the fourth becomes -2x to the fourth. The 4x to the third becomes -4x to the third. And then -2x squared becomes +2x squared. Once we've changed all of those signs, now we either add or subtract to combine the like terms. Notice how when I wrote the like terms, I placed the powers for my like terms underneath the power that matched them above. So we will subtract 2x to the fourth minus 2x to the fourth and get 0x to the fourth. We'll take x to the third minus 4x to the third, remembering that x to the third up here will have the invisible 1, so we'll have 1 minus 4, which is -3x to the third. And then -2x squared plus +2x squared will give us 0x squared. Any remaining terms we bring down. Therefore, now our remaining polynomial is -3x to the third plus 0x squared plus 15x minus 6. Now we will repeat this entire process starting again from step 1. We will now divide the leading terms once again, but now we have a different leading term. That's -3x to the third. We will still divide it by the leading term on the left, that's x squared. We'll take negative 3x to the third over x squared. If we take negative 3 over the invisible 1, we'll get negative 3 as our constant. And if we take x to the third over x squared, we get x. Once again, we write this number above the bar and multiply that negative 3x again by each of the terms to the left of the division symbol. So negative 3x times x squared will give us negative 3x to the third. Negative 3x times positive 2x will give us negative 6x squared. And negative 3x times negative 1 will give us positive 3x. Then we change all of our signs. So the 3x to the third was negative, it becomes positive. The negative 6x squared was negative, it becomes positive. And the positive 3x changes to negative. Now if we do our math, negative 3x to the third plus 3x to the third will cancel. 0x squared plus 6x squared gives us 6x squared. And then 15x minus 3x gives us positive 12x, still minus 6. We'll do this process again. Once again, let's divide the leading terms going back to step 1. Our new leading term is 6x squared. We'll take that over the leading term to the left of our division symbol, that is still just x squared. We'll write the invisible 1 in, and we'll divide. If we divide, the x squares will cancel out and give us a constant that's 6 over 1 for 6. We'll write plus 6 as our next term, and we'll take that 6 times each of the terms on the left of the division symbol. If we take 6 times x squared, we will get 6x squared. If we take 6 times 2x, we'll get 12x. And if we take 6 times negative 1, we'll get negative 6. Then we'll change each of the signs. So our 6x squared becomes negative 6x squared, our 12x becomes negative 12x, and our negative 6 becomes positive 6. Then when we subtract, we'll get 6x squared minus 6x squared, which cancels, 12x minus 12x, which cancels, and the negative 6 plus 6, which cancels. We have nothing left at all, and our remainder is 0. Now you may be confused about when you're allowed to stop if you get something other than 0. In general, if your remainder is lower power than the number you're dividing by, that's when it's time to stop. Notice our first remainder was third power, which is higher power than what we're dividing by, that's x squared. Our next remainder was second power, which is the same as what we're dividing by. And finally, the remainder that we ended up with after that operation is 0 power, because 0 is a constant. So now we've carried out the long division of these polynomials. For our final answer, we will say our quotient will be this number composed of the terms that we got when we did our divisions. So our quotient is 2x squared minus 3x plus 6, and our remainder is 0.